What if, by 2100, humanity had transformed Mars from a lifeless desert into a thriving hub of innovation? Picture this: a world where astronauts no longer visit Mars. They live here. What would that future look like? Could this be humanity's next chapter? Dare to imagine a speculative glimpse into 2100, a time when the Red Planet hosts our first self-sustaining outpost. A place where science fiction becomes science fact. But how? What technologies would make survival possible? And what sacrifices would we endure to call Mars home? This is not a documentary. This is a what if, a vision of what might be. So strap in. Let's explore the hypothetical 2100, the year humanity learned to thrive on Mars. This station isn't just a habitat, it's a multi-purpose hub. First, it's a scientific powerhouse. Geologists study ancient riverbeds for clues about Mars' wet past. Biologists hunt for microbial life in subsurface ice. Climatologists map dust storms to predict weather patterns. Second, it's a test bed for survival. Every system here, from air recycling to water extraction, proves we can live off-world. Third, it's a stepping stone. Technologies refined here will pave the way for colonies on moons of Jupiter or even interstellar travel. But above all, this station answers a timeless question: can humanity thrive beyond Earth? The station is a mosaic of cutting-edge engineering. Residential modules shielded by meters of regolith, house-rotating crews. Transparent biodomes glow with LED-lit crops. Underground manufacturing bays hum with 3D printers turning Martian dirt into tools. At its heart lies the energy plant, a hybrid system of nuclear reactors and solar arrays, powering everything from life support to quantum computers. But the station isn't static. Modular design allows expansion. New labs, greenhouses, or storage units snap into place like interlocking puzzles. Who calls this place home? A rotating population of 5,200 pioneers. Geologists spend months mapping canyons. Engineers troubleshoot life support glitches. Medics study how low gravity affects muscle density. Crews rotate every 2 years, but some stay longer, adapting to Martian rhythms. Daily life blends routine and wonder. Mornings start with algae-based smoothies, afternoons with rover expeditions, evenings with stargazing through radiation-shielded observatories. Yet challenges persist: isolation, equipment failures, the constant hum of air recyclers. Survival here demands teamwork, creativity, and resilience. Meet the unsung heroes, autonomous systems that keep the station running. Solar drones scout for ice deposits, relaying maps to mission control. Construction bots 3D print walls using molten regolith, their lasers dancing in the thin air. Inside, maintenance droids glide through corridors, scanning for air leaks or faulty wiring. These machines don't sleep. They mine, manufacture, and monitor, freeing humans for tasks requiring intuition and adaptability. Human-robot partnerships are seamless. Astronauts command drones with augmented reality goggles, their gestures translating into precise robotic actions. Earth won't supply this station forever. Instead, Mars itself provides. Subsurface ice is melted into water, split into oxygen for breathing and hydrogen for fuel. Algae cultures scrub CO2 from the air, while vertical farms grow potatoes, beans, and genetically modified Martian wheat under pink LED lights. Even the dirt is useful. Regolith is baked into bricks or melted into glass. Nothing is wasted. Yesterday's table scraps become tomorrow's fertilizer. This closed-loop system isn't just sustainable, it's revolutionary. While the station prioritizes self-reliance, it occasionally ships treasures home. Rare minerals etched by ancient water reveal clues about the solar system's history. Propellant, methane synthesized from atmospheric CO2, fuels return missions. Data flows constantly. Atmospheric readings, genetic profiles of extremophile, microbes, and blueprints for Mars-tested technologies. These exports are small but transformative, proving that interplanetary trade isn't science fiction. Arriving on Mars is a ballet of physics and precision. Crewed ships dock at a low-orbit station where astronauts acclimatize before descending. Cargo pods, launched via electromagnetic rails, pierce the sky without rockets. Returning vehicles refuel with locally made methane, their ascent a fiery streak against the pink horizon. Every landing and launch is a triumph, a reminder that Mars is no longer a one-way journey. Mars doesn't welcome visitors. Radiation bombards the surface. Dust storms blot out the sun for months. Micrometeoroids pepper the hull. Yet the station endures. Habitats are buried under regolith or shielded by water-jacketed walls. Electrostatic grids repel dust, keeping solar panels functional. Quantum encrypted networks thwart cyber attacks. And if disaster strikes, say, a hull breach, crews retreat to underground bunkers while repair bots seal the leak. Survival here isn't luck, it's design. Could Mars ever resemble Earth? By 2100, the answer is a cautious maybe. Experiments are underway. Orbital mirrors beam extra sunlight to melt ice caps, releasing CO2. Algae carpets spread across valleys, exhaling oxygen. Biodomes simulate Earth ecosystems, testing how plants and microbes might terraform the surface. It's a centuries-long project, fraught with ethical questions. Should we alter another planet? The station's scientists debate this daily. For now, their work focuses on small victories, warmer pockets of air, hardier crops, and the faint hope of a greener future. The Martian station of 2100 isn't just a habitat. It's a promise that humanity can adapt, innovate, and reach beyond its cradle. Every module, every robot, every experiment brings us closer to becoming a multiplanetary species. The challenges are immense, but so is our resolve. As this station evolves, so do we, redefining what it means to live, work, and dream among the stars. Want to see more visions of the future? Hit subscribe.